Hello everyone, welcome to another video of Thermodynamics 2. In this video, I'm going to discuss activity 2 in the lecture guide 20. Um, so this is the problem. For your reference, I have shared that in this video. Air at 100 kPa and 15 degrees Celsius and 60% relative humidity is first heated to 20 degrees Celsius in a heating section and then humidified by introducing water vapor. The air leaves the humidifying section at 25 degrees Celsius and 65% relative humidity. Determine the amount of steam added to air and the amount of heat transferred to the air in the heating section. So let's think about a schematic diagram. So schematic diagram is pretty similar to, it's the same as figure 2 in this handout. So if I share my screen, the other screen, stop sharing, and then add the whiteboard here. So I can draw a similar diagram. You have a heating coil in the heating section, and then we have a humidifier in this section. So this is the heating section. This is state 1 or section 1 to state 2. And then the final state is 3. So data given is, given pressure 100 kilopascal. T1 is 15 degrees Celsius. So that's a dry bulb temperature. And relative humidity is given V1, it's 60%. And then we also have first heated to 20 Celsius. So T2 is 20 degrees Celsius. We don't know what V2 is. Omega 1, we can find omega 1 from the psychrometric chart, and omega 2 is equal to omega 1 because there's no addition of water vapor. So then specific humidity is the same. Specific humidity is the same. Now T3 is given 25 degrees Celsius, and V3 is given 65%. Now we have, we need to find what the question is, question 1, and the amount of steam added to the air. So the amount of steam added can be found if you know what the value of omega 2 and omega 3, because the amount of steam added is equal to actually we can only find that per unit mass of dry air. So its amount of steam added is equal to mv3 minus mv1. So I should write this v as subscript. The mass of vapor at 3 minus mass of vapor at 2. So we know that by definition omega is mass of vapor divided by mass of dry air. So if I divide this steam added divided by the mass of dry air, so is equal to mass of vapor 3 divided by dry air minus mass of vapor 2 divided by amount of dry air. So this is actually omega 3 minus omega 2. So that's what we need to find. Now to find omega 3 and omega 2, we can do it either by using equations or we can use the psychrometric chart. In this case, suggest you to use psychrometric chart. So to use the psychrometric chart, we go to this and then share the share psychrometric chart screen. Let's see, you have it. Okay, let's open it up. So this is the psychrometric chart. Yeah, you see that. Okay, so the condition at the condition at 1 is 15 degrees Celsius and 60%. So let me make it a little bit bigger. So this is 15 degrees Celsius. This one is 15. And then have 60%. 60% is this. Right? So that's our state 1. And then it's a simple heating. So we can draw, just need to raise this one a little bit. 60% and 50 is here. And going to draw a straight line. This one. Draw straight line until it hits 20 degrees Celsius, and that's right here. So 20 degrees Celsius is here. Okay. And then I'm going to actually reduce the thickness 5 and and then the that's at 20. Okay, 20 degrees Celsius is not there. Just need to erase a little bit of this one and this point as well. This one and then draw a straight line and goes to 20 degrees here. Different color, probably a little bit brighter one or darker. Pick that one. So 20 about this point, 2, and then 3 is 625 and 65%. So 25 is make it a different color. So we have 25 is here. And along this line, you go to 65, somewhere at the middle. So this is 3. Okay. So 2 to 3, I would say pick this color. And that. That's how 3. I just connected those 2 points, 3 in here. So these are 1, 2, 3 points. So we can find what those enthalpies are. So, and also we can find what the omegas. So I pick this color. So if we would find the omega, I can draw straight line to this axis. So we have omega in humidity ratio, grams moisture per kilogram. So it's kilogram. If you multiply by 10 to the power -3. So this is 10, 12, 14. It's in the middle. So it's around like 13, I would say. So this is 14 humidity ratio. So this line is 13.5. So this is 13. So this is 13 times. So write it in terms of 13 here. And then if I take the blue line, straight to that, that will give us omega 2. This is 6.5, 7.58. So this is close to 6.5, 6.4. Let's say 6.4. This is 6.4 grams per kilogram of dry air. So this is also grams per kilogram of dry air. Okay. That's fine, omega 1 and omega 2. So 6.4, 13 pound. And then I'm going to stop share this. Sharing. And then share back my whiteboard. And then goes the value I got. This is 13 minus 6.4 grams of moisture per kilogram of dry air. So this is 6.6 times 10 to the power -3 kilograms of moisture per kilogram of dry air. So if I write it in terms of 0.0066 kilograms per kilogram of dry air, right? So that's what it is. So this much of moisture is added in the humidification. Now we want to find the amount of heat transfer. So to find the amount of heat transfer, if you get this this control volume here, and apply the first law of thermodynamics, there you get Q added, right, minus or plus m dot A right? H1 minus H2 equals 0. And then we can find this one Q added per unit mass flow rate of dry air. So H2 minus H1. So now it's the problem of finding H1 and H2. So let's go back to our psychrometric chart. Psychrometric chart is here. Here, okay. So share it, share screen. Share psychrometric chart. Psychrometric chart. And now we want to draw the line. Take a red color for this one. I need red. That are parallel to these lines. This is 10 wet bulb temperature, but 30 temperature. Right here. So it's equal to close to, this is 30, 31, 32, very close to 32. And I take another line from this from here. So parallel to these lines. Okay, so this much is heat added. So this is in red color. I can say this is 32 close to, and the other one is 32, 33, 34, 35, 36. So it's around 36, 36, 37, 38, 39, 40. So it's around 36, right? So we can say we share your screen. So this is 36 minus 32, 4 kilojoules per kilogram of dry air. So that's what the answer, two answers for the activity 2 questions. So thank you very much for watching. See you in another video.